Let's take a look at the conductor evolutions in the past 100+ years. There has been new type of conductors introduced, but none of them really became mainstream except the ACSR technology that was invented in 1908. And there's a reason why, and there's also a reason why these various types of new conductor technology were introduced, but weren't really successful in becoming the mainstream. Let's start with the ACSR technology, which was invented in 1908. At the time, we had high-strength steel, but it is not quite high-strength enough. So we had to leverage the strength contribution from aluminum, namely the hard aluminum. When you use hard aluminum in the conductor, you do have a challenge because hard aluminum, they will convert into annealed aluminum if you go above the temperature of 93 degrees centigrade. So ACSR technology has that inherent limitation in ampacity because they cannot operate at high temperatures. To solve that handicap in limiting ampacity, ACSS conductor technology was developed about 50 years ago. At the time, our steel industry was able to introduce stronger steel, which allowed the conductor to combine with annealed aluminum that does not have the temperature limit in ACSR. So now you have a conductor that can go to high temperature for high ampacity. The problem, however, is the fact that we have steel in the core, which has very high thermal expansion, which leads to excessive thermal sagging. So now you have a conductor that does give you high ampacity, but it has this serious challenge of high thermal sag. So to solve that high sag issue, in the 1990s, we have advanced conductor emerging, which I would call first generation advanced conductor, where composite material with lower thermal expansion was used to replace steel. Now you have a conductor that can go to high temperature for high ampacity, yet the thermal sagging was effectively managed by the lower thermal expansion in the strength material. However, these type of advanced conductors are known to be delicate, difficult to work with, easy to break, with longevity concerns, and they are also pricey because these are niche products. And this led to the discovery or invention of TS technology, where in the TS configuration, there's an effective protection of the carbon core with the aluminum encapsulation. And the aluminum encapsulation has sufficient thickness in it so that we can preserve the pretensioning of the carbon core to address the fundamental limitation in terms of compression failure when the first generation advanced conductor were bent in the field. Now you have a solution that is compatible with traditional way of doing conductor installation, conductor maintenance, and conductor repair. We basically use the same tool, same equipment, same methodology, and same training. We also have the composite core protected from day one all the way through end of life of the conductor. We eliminated the degradation mechanism to the composite core from environmental factors such as moisture degradation, oxidation problem at high temperature, UV and ozone, which is very detrimental if the conductor had birdcage that weren't repaired.